Okay, now we have we'll do some like a simple equation oriented modeling in Aspen Plus. So I made here like an example. So C3 splitter. So we have the feed 25 degree C, 25 bar, and it's about 80% sorry, C2 splitter, 30% ethylene, and then 20% ethylene, and then 20% ethane. And then the column itself is basically um, yeah, 100 stages, and then total condenser, and then we have this rate as one of the our degree of freedom, 30 ton an hour, and then the reflux ratio of 4, right? And then if we run this in a normal Aspen Plus, I think if I go to this equation oriented, I have to change this back to sequential modeler, and then if we run this, be patient a bit. Okay, so if we run this reflux ratio of 4, this level of 30, 39 tons, and then we'll get the result in this result tab. You can see top temperature minus 29 degrees C, and then this is the reflux ratio of 4, and then the reflux rate of if you change the basis to mass, you will get 39,000 ton, right? 39,000 kilogram an hour, which is 39 ton. So that's the simple one. And so if you want to change this to equation oriented, we can simply go like I did, equation oriented mode. And then the scope is the plant. This is then the whole flow sheet is then the whole plant basically. And then we run in the simulation mode, for example, in this case. But before we do so, let's go through this. Important things for now is that in equation oriented we can swap things. Yeah, as you recall, we use distillate rate and then reflux ratio as the independent variables. And if we want to control, and then the concentrations over here, this layer and bottom, they are like calculated values. So if we want to control, for example, want to want to achieve a certain concentrations over here, we typically use design spec, and then we vary, for example, the reflux ratio or the distillate rate. But then in EO, we can simply swap these concentrations from calculated currently to constant, and then the distillate rate and the reflux ratio from constant to calculated. So the way we do so is that we go to the EO spec groups, right? In this EO configuration yeah, part, and then we go to the spec group, and then what we do there, so we need to configure something, but before we do so, we will have to run this once, so that whatever the one that we mentioned before, all of those distillate rates and the reflux ratio and then the other associated variables, they are tabulated in the whole EO variables. So we run this once so that we can get all variables. So what I have done before is that we can see what the EO variables is. Yeah. So all of these are the EO variables related to this to the plant basically. So we have so we have variables. So we have all of this. C2S means the name of the block, C2S, and then the feed is then this feed, so block feed. So and then the stream, and then moles. So this is then the mole flow rate of that feed stream, and then it goes to the temperature, pressure, enthalpy, molar volume, and then the concentration, which is contents. So that's the type is then contents, and then all the specifications are calculated over here. And then the same goes with the distillate stream, and then the bottom streams, and all the other, depending on for each page. We have 1274 variables that we have over here, so it's a lot. So these are the variables that are being used to model this. And then if you can then double click and then see what the constants are. So the constants are, like for example in this case, the so in the one that I did, what I did now is that if we go to here, so I create a new spec groups in the EO tab, create new spec groups, and then I describe it as like a fixed tower composition. And then if I go to the specification and then the CO comes, right, the one that I just named, I put like a distillate stream, the ethane in the distillate stream as a constant, and then ethylene in the bottom stream as a constant. And then I swap it. This is previously in the sequential molder, these are like calculated. I swap it as constants, and then the ones that are constants, this is like rate, and then the reflux ratio, we swap it as a calculate. Right, so we have like two variables swapped from calculated to constants, and then the other two variables swapped from constants to calculated. So because of this, and I put like active, I could see that these two are now constant. But then if I deactivate this, right, for example, and then I rerun that again. So those variables are gone. So if we can see, so the concentrations of ethane in the top and then concentrations of ethylene in the bottom, they are now calculated, no longer constant. And then this distillation rate and then the reflux ratio are now constant, as in the case of the sequential molder, right? Now, how to define this is simply like you make a new and then make a description and then put it active, and then in the spec you can just simply, if you go here for example, and then right, so we get here, and then you can then find if you have more than a few units, you can click drop down over here and then select the block which I've selected over here, and then we can just simply go to the feed stream, distillate streams, bottom streams, and then all the other details of the column. Or we can simply make a query and then find the stream, for example. And then click OK. Yeah, nothing. Yeah, I need to find what the code is. Yeah. But nonetheless, that's how we can try to make minimize the search button. And then once we get all of this, and then we can just simply change the spec from calculated to constant or constant to calculated, the other way around, and then that's it. So we have all of this, and then because we now specifying these two variables as constants, we can just simply go to the input, EO input, and then in the EO input, what I did, these are like the same variables, so we have to define it over here, find the same variables over here, and then we just put the number here. So how much do we want? So for example, we want to have like a minimum ethane in the top stream, in the distillate stream, and also as minimum ethylene in the bottom stream. And then this is like contents, that's the name of the physical type, and then the unit is fraction. If we are not really sure about this, and then we better go to the to this page so that we can know what are the typical physical types of the variables and the specifications of the variables, and then put lower bound and upper bound, otherwise it won't run. So once we do so, and then Now we have, like, for example, we go to the flow sheet. If I deactivate this, um, it will use the reflux ratio of 4 and then 39 ton an hour of uh, um distillate rate, right? So as we have seen before. Yeah, it's no longer the same number, so we have to sequential modeler, and then we purge all the simulation results. And then we run this again so that we get the initial value. Right, these two. And then, as you know, if we use design spec, you will then do the iteration, but then in the equation oriented, it doesn't do the iteration, it solves everything at once. So what would be the distillate rate and then the reflux ratio? Because when we swap, we ask these two to be calculated to achieve these numbers. Okay, so we go to the spec group and activate this again. Okay, we deactivate it and then we change this to equation oriented and we do simulation. Okay, and then we run this and then we should get then these numbers. So to get to those composition, we will need to run 39.2 and then this is 3.7 instead of 4. Okay, so in the next video we will then deep dive into how to do optimization, because in the equation oriented we have we have 4 modes: simulation, parameter estimation, reconciliations, and optimizations. And I normally use these two: simulation and optimization. So we will see how we can do optimization. Okay, bye bye.